Welcome back to physics. It's Mr. Craig. Looking at kinematics again, and now we're looking at using the kinematics formulas to find some information that we want to get. For instance, if you had some velocities and times, can you find out what the acceleration the person was feeling when they were falling? Or if you had a person stopping at a red light and they had to put on the brakes, and they had a distance and they had their initial velocity, could you find out how much time it took to stop and also what their deceleration was? So we're going to look at 4 examples today. First one is called the Kinematics from California Adventure Park, which is part of the Disneyland Resort. It used to be called California Screamin'. And it's got some information on it. It actually speeds you up to 89 kilometers per hour, which is about, we'll calculate it in a moment, but we've got to get it in meters per second. And it does it in 4.04 seconds. And we'll find out what the acceleration is that you would feel on that ride and what distance it took in your acceleration. Stats for the ride. It accelerates you from 0 speed to 24.7 meters per second, which is 89 kilometers an hour, about 55 miles an hour. And it does it in consistently, for our students who went to California Park, about 4.04, 4.05 seconds. So what we want to do is calculate or find out what the acceleration was that they felt and what distance was covered along the track as they accelerated for that 4.04 seconds. What I want to do is read through the word problem of the question and then figure out, of the 5 variables in kinematics, the d, vi, vf, a, and t, what are you given and then what do you need to find? They said that we needed to find out the acceleration, so we know that's a question mark. They also said we needed to find out what the distance was that the roller coaster went down the track as it was accelerating, so we need to find that too. Hopefully we have the other 3 variables, and we do. They said we started at 0, and you can see that in the video. And you can see in the video you get up to a pretty high speed. In fact, it's 24.7 radar gunned meters per second. And the time, numerous students, we got the average, 4.04 seconds. So what we're trying to find right now is, what is the acceleration? So we'll look for that one right now. To get the acceleration, we have to have a formula that has VI, which we know, VF, which we know, T, which we know, and A, which we don't. So you need to have 3 knowns and the 1 unknown. And there's only one formula that has that. It's VF equals VI plus AT. So it's got the VI, it's got VF, it's got A, which we don't know, and it's got T, which we know. So it's got 3 knowns, 1 unknown. 1 equation, 1 unknown, we can solve it. So I'm just going to put the numbers in here, but 24.7 is equal to 0, which is what we started at, plus A, which is what we're looking for, times the time. So to clean it up and make it look like a math equation, I've got 24.7, this 0 doesn't mean anything, is equal to A times 4.04, which is the same as 4.04 times A. So it's like 24 is equal to 4.04x. So let's calculate A. See your calculator and proper bed mass, proper algebra. 24.7 is equal to 4.04a. You have to divide this side by 4.4, divide the 24.7 by 4.04, which we did. And when you do that calculation, you get 6.12 meters per second squared, which is a noticeable jolt. If you ever go on that ride, you know you get pushed back into your seat quite noticeably. This is like a typical car taking off from a red light at double the acceleration. So this is quite similar to what you get on a jet when it takes off. Just by the way, if you were wondering how many G's you were pushing on this ride, 1 G is about 10 meters per second squared. In fact, it's the acceleration due to gravity. It's 9.8 meters per second squared. So this is about 2/3 of a g that you're pushing at takeoff on this Incredicoaster roller coaster. So we've got the acceleration. Now we're going to find out the d, the distance down the track, or the displacement down the track that you traveled. So we're looking for d, the distance down the track, or displacement down the track that you go while you're accelerating. I have 4 variables now. I only have 1 unknown. I could use any equation that has d in it because I now have the acceleration. So it doesn't matter which equation has d in it, you should get the same answer. You have to get the same answer no matter which one you use. I'm just going to use one that's easy for me, any equation that has d in it. So I will just pick one. D is equal to VIT plus 1/2 a t squared. I'll just get d right away from it. And when I put the numbers in, I get d is equal to 0 times t, 4.4, plus 1/2 is just really 0.5 times the acceleration, which we had 6.12, times t squared. So if I simplify this, I get d is equal to, this whole thing is 0. 0 times anything is 0. Plus 0.5 times 6.12 times t squared. And just to clean this up a little bit, d is equal to 0.5 times 6.12. It's just half of 6.12. So it's like 3.06. That's half of 6.12. It's literally 6.12 times 0.5. And then times t squared. The d, t, I've got t, I can put it in, because I can't have an equation with 2 unknowns. I already know what the t is. So 4.04 squared. And if I calculate my answer, I'll know my distance. I just go 4.04 squared times 6.12 times 0.5, or do what I did here. It's the same thing mathematically. And I get an answer of 49.9 meters down the track. And you can see that in the video. It's about half of a 100-meter sprint track. The next problem is near and dear to my heart. It's water slide, free fall water slide at Disney World at a place called Blizzard Beach. It's a big water park. And Summit Plummet is, it's like the free fall at Cultus Lake, except it's another 50 feet higher. So it's about 120 feet high instead of 70 feet high. And you fall and fall and fall. And in fact, you fall so long, so much time under the influence of gravity that you end up getting a speed of about 60 miles an hour before you hit the water at the bottom. And I didn't believe this, and neither did the students at first. So we brought our radar guns to Disney World, and they let us use them. They had a radar gun as well, and ours mirrored what theirs got. Students were going 60 miles an hour at the bottom. And the danger is with 60 miles an hour at the bottom of the water slide, and there's only water to slow you down, and it's in a fairly short tank, you may end up ripping parts of your bathing suit off. And some people were having that problem then. And a couple people had to fix their bathing suits. One person actually had to get a new bathing suit too. But that's what happens when you come into the tank and you're going 60 miles an hour and you have to decelerate to 0 very quickly. So the facts for this particular water slide are coming up right now. So here's the information. D, VI, VF, A, and T, those are the 5 variables of kinematics. And from the situation they gave us here, we get the information that they give us, and then from that we hopefully will have enough information using our kinematics equations to find what we need to find. The big question here is, what deceleration did that person have that could have been catastrophic for their bathing suit. We had a VI, they hit the water at the bottom at 26.7 meters per second, which is 60 miles an hour. Their speed at the end of the tank, where they came to a stop, was 0 meters per second, of course. And the time that it took, we used numerous students and measured the time that it took for them to stop, and it was on average about 2.65 seconds. So what we want to do is find out, hey, what was their deceleration? So I need an equation that has VI, VF, A, and T in it. Because I know T, VF, and VI, I can only have one unknown that I'm looking for. So I have to have an equation with those 4 variables in it. And that is the equation. So again, I'll just put the numbers in like I did last time. 0 is the final speed. The initial speed coming in was 26.7. The acceleration, don't know it, but I'm looking for it, times the time, 2.65. If I solve this, I want to have numbers on one side and variables on the other. So to do that, I know the variable is A, so I have to keep that on this side. This is A times 2.65, which is the same as 2.65 A. This is 26.7 on this side, but I don't want it here. I want it so that there's no number here and it's on the other side. So I have to take 26.7 away from this side and away from this side. So I get minus 26.7 is equal to 0. So I've just literally brought it over to the other side. So this equation simplifies to minus 26.7 is equal to 2.65 A. And I don't want 2.65 A, I just want A. So I have to divide this side by 2.65. So divide this side by 2.65, and I get A. And then I have to divide this side by 2.65. And now I'm pretty close to the answer. We'll calculate it and see what it is. When you put those numbers into your calculator, you get minus 10.1 meters per second squared. That means that you have an acceleration of minus 10.1. That's the same thing as saying I decelerated at 10.1 meters per second squared. Just remember, 1 g is about 10 meters per second squared. So this person actually felt 1 g as they were decelerating. So they felt like they were under the influence of gravity squishing them together as they came to a stop. Safe for the person, but maybe not safe for the bathing suit. This example from cliff jumping, and you'll see that on my YouTube, they've given us a whole bunch of information like how far the person fell, 58.8 meters falling, like downward. You have to put the negative sign in there. Down's negative, positive is upward, okay? Acceleration of gravity is 9.8 meters per second squared down, so you have to put the negative in there. So they gave us the time that it took to fall, they gave us the distance, and they also told us that the person was going 123 kilometers per hour before they hit the water. We're going to calculate that and see if that really is true. You could use VF equals VI plus AT again, but I'm just going to use a different equation. I'll say, hey, yeah, they gave us the D, so I'm going to use an equation that has D, VI, VF, and A in it. I should get the same answer if I use this equation though. Finish the calculation. VF is 33.9 meters per second, which when you multiply by the conversion factor to get to kilometers per hour, which is 3.6, go 33.9 times 3.6 and you get 122-ish kilometers per hour, which is pretty close to what they said it was. Let's try that other equation, the VF equals VI plus AT, and see if we get the same 33.9. VI was 0, A was minus 9.8, time was 3.58, and let's see if we get it. Should be the same answer as we got from the previous equation. Darn close. Some of their data might have been wrong, which resulted in the difference between the two answers, but they should be exactly the same.